right. Can you guys hear me? Okay, I think they can hear me. They're just half asleep from eating too much. All right. Welcome. For the duration of this talk, I'm going to speak about JavaScript performance. If you have questions, please scan the QR code or open the collaborative text document and write your questions on the pad as we go. And I'll take a look at the end and answer any questions that are on the pad. All right. So before we start, my name is Sam. I've been working at Odoo since 2019. Since 2020, I've been a part of the JavaScript framework team. And as part of my work in the JavaScript framework team, I've had to improve and debug performance on various things that are done on the client side. And so today I'll be talking a little bit about JavaScript performance and tips and tricks, things to avoid, things that you should do one way rather than another. Hopefully, if you're working within the confines of the Odoo framework, you shouldn't worry about this too much. For the most part, you should never have enough data in memory that you need to care too deeply about performance, but a lot of this stuff can be useful if you end up in a pickle. And also, if you need to diagnose a problem just so that you can tell us that our code sucks and we need to fix it. So I'm going to start with the 7 performance mantras. Those are 7 steps to improve the performance of your applications that have been coined by Brendan Gregg, who's a performance engineer, previously at Sun Microsystems and then at Netflix. He has a great site about everything performance with lots and lots of neat tools and approach how to diagnose performance problem, and I warmly recommend that you check out his website. So these are the 7 performance mantras, and they are in order of things that you should start doing, and we'll see that some of this stuff is not as intuitive as it might seem, and I'll give you a few examples of how you can apply this in the JavaScript ecosystem. So the first performance mantra is don't do it. It seems pretty obvious, but doing nothing is always faster than doing anything, even if you're doing it really, really fast. So if you can avoid doing things, just don't do them. Being lazy applies also to your code. Just write less code, and you'll have less code to optimize. The first tip that you have for this one is remove zombie code. Zombie code is code that's not quite dead, but also not quite alive. It's one of the things that is just completely useless, but ends up in your code base invariably when you're maintaining a software code base for a while. You've got code that computes values that nobody cares about, nobody reads anymore. It's never shown on the screen. So I don't have any great tips for finding this code. Obviously, if it was easy to find, you probably wouldn't have it still, but it's some of the things like just cruft that you can remove. The other thing is only do as much work as you need to. This can mean multiple things. One is don't do stuff that you might need eventually, because you also might not need it eventually, so just don't do that work. And this also means sometimes pushing back on the requirements when you have a product owner or a customer that really wants something to be done. Sometimes it just doesn't make sense. It's going to be a lot of work. It's going to be really slow anyway. So find some way that the customer or the product owner can work around their issue without writing code. And this one is kind of specific to JavaScript code. If you want your JavaScript application to be fast, just don't do things in JavaScript, do them on the server. So devices that run Odoo can be anything. They can be mobile devices. You don't know how powerful they are. And so if you want something to be fast, just do it with your server hardware that you know is fast. And then you don't have to worry about the web application being slow. The next big point is don't do it again. And this one is simply to say that caching is good. Cache all the things. And there are many things that you should cache. Some things that are very specific to JavaScript is network calls. So while you could do this in Python, typically it doesn't make much sense, especially not with unbounded caches. But the thing that's nice with JavaScript, especially JavaScript in the Odoo ecosystem, is that session length is kind of hard capped. At some point, the user is going to refresh their page. If you're using Odoo Online, we update your instances every week. And so that means that in the worst case, a session is 1 week old. But for most people, they turn on their computer when they get to work, and then they turn it off when they leave. and so the session is at most 1 day old. You shouldn't be afraid of unbounded caches in JavaScript the same way that you are afraid of unbounded caches on the server, because obviously these can live for much longer. Another thing that you should cache is DOM element measurements. This is one thing that might not be obvious to everyone, but measuring things in the DOM can be expensive. When you need to measure the position or the width or the height of an HTML element, what you're saying to the browser is, I need to know now where this element is in the page. And if for some reason the layout that the browser computed for the previous paint of the interface is no longer valid because you changed the style of some element, you added some CSS class, or you just move some element around, by doing a DOM element measurement, you're forcing the browser to redo all of the layout work to know where each element is on the page and on the screen. And so this you should do as early as possible in the lifecycle and keep it in cache if ever possible. The last thing, which is pretty obvious, is expensive pure function. If you have to do some heavy data processing stuff, anything where the output is a direct function of the input, keep it in cache. So there are a few tools that you can use to keep things in cache. The first one is the most basic and blunt tool. Just use a local variable. Here I have an example where we're measuring the dimensions of a DOM element. Instead of doing it twice, once for the width and once for the height, just store this in a local variable. Keep using it for the rest of the function. If you're writing synchronous code, you're sure that this data is valid for the entire execution of the function. The next tool that you can use is this function that we have in the JavaScript framework. It's called memoize, and what it does is it takes a function and it turns it into a function with an extra layer of cache. What it does is it caches the return values based on the value of the first argument of the underlying function. If you need a more advanced caching strategy, and especially if you want a bounded cache, not an unbounded cache, because memoize is unbounded for the reasons I explained earlier, you can write a custom cache. It's not that much work, and it can be very much worth it. The next thing would be doing things less, like doing the same thing, but just doing it when it actually matters. And the one thing that's quite specific to the browser is you shouldn't do work if the browser won't ever be able to paint it. So don't do things between animation frames. Do it once per frame at maximum. Otherwise, you're just computing work that's going to be thrown away because you're going to override it before the frame is painted. And the other common case would be when the user is still interacting with the page. Typically, this would be what we call a debounce, when the user is typing in an input and we need to do some search on the server. There's no point in spamming the server with a request every time the user has pressed a single key on their keyboard. Just wait for them to have stopped typing for like 500 milliseconds before you ask the server. Save your server some work. So there are some tools that you can use in the framework. The first one would be use throttle for animation. This one is very similar to memoize in that it takes a function and it will, if you call this function more than once a frame, it will delay the call until right before the frame is painted and call it at that point. And so this means that anything that you need to do for animations, like if you have, for example, a tooltip and you need to reposition it, there's no point in repositioning it until the browser is about to paint it, so use this kind of stuff. The other one is use debounced. Use debounced is what I was saying earlier with the input. It takes a function and it waits for the function to have been called, to have not been called for at least some amount of time that you specify. It can be 500 milliseconds generally. That's a good starting point. You can go lower if you want something that's a little more snappy and reactive, but that's generally a good starting point. There are also standalone versions of these functions. So these two are hooks that you can use in OWL components. And if you're using these in components, you really should use the hook version. What they do is that when the component gets destroyed, the last scheduled call will be canceled. And this is important because if inside of the code that you're wrapping, you're assuming that the component is alive for whatever reason, like you're reading the state, you're reading a ref, whatever, this might crash if the function gets executed after the components gets destroyed, and so you should use these. But if you need to have these same capabilities outside of owl components, we have standalone versions of these functions that you can use. The next point would be doing it later, and this one is about being lazy. So developers are famous for being lazy, trying to do the easy thing, but the thing that should be lazy is not just you, but also your code. Don't compute things until you need them. And that can include not rendering invisible components. So what people used to do a lot before OWL was the main way to do UI stuff inside of Odoo is that the widgets would render all of the elements that they could ever possibly want, and some of them would have this dnon class. They would be just not displayed, but they would still be rendered. And it kind of made sense at the time because rendering new things was difficult, but with OWL, it's really not. And so if you're using display none instead of just not rendering stuff with the t-if directive, you're just doing wasted work. The other thing would be computing expensive things on access. So if you have objects where a property is expensive to compute and unlikely to be accessed, just use a getter or something. So the tools that you can use to solve these kind of issues would be, as I was saying, use a t-if directive instead of a dnon class. In this example, you can see that at the top, the subcomponent will be always rendered. This means that it gets instantiated. If this component has a subtree of components, this entire subtree of components gets rendered, and this is expensive work. So instead of doing that, use a t-if, and that means that in the case where the component doesn't need to be shown, it also doesn't get rendered, it doesn't take CPU cycles, and all is good. Other tools that you can use would be paging. This is typically what we do in the list view. Your users, they can't see 100,000 records at a time. Just show them 80, and if they need more, they can click on the next page and get the next 80 records. In some cases, you want to actually have a lot of records accessible without paging, and for that you can use list virtualization. This is a technique that consists in only displaying or rendering the elements that will be visible inside the viewport. So if you have a very long list, you don't want to render everything that's way above the screen or way below the screen. And so for that, we have this hook called useVirtual that takes a list. You tell it the height of the elements, and then it handles, when you scroll, selecting which rows of the list should be rendered and which ones should not. And this lets you have virtually unlimited lengths for your lists. And then the last one, and the bluntest one, would be getters. So in this example on the bottom, we have this eval context, and this is something that we actually had at some point in our code base. Computing the eval context involves evaluating Python expressions with our JavaScript Python interpreter. It can be expensive, and this is needed by some fields in some views, but most fields never read this value. And at some point, we were computing this for every single field in every single view. And so in a list view with 80 lines, 10 columns, that's 800 times where we're computing this thing that probably no field in the view is even reading. So don't do that. And if it's really expensive, you can even make the getter overwrite itself after the property has been computed so that it's only computed the first time it's accessed. And so that's kind of like mixing memoization with lazy computation. The next one is do it when no one is looking. And this one is not obvious. I think we don't do this a lot even within Odoo, but use CPU cycles when the user won't feel it. And that means that, for example, when the user interacts with the page, and for example, you need to look up something in the cache, and now let's say you have a bounded cache, you want to evict elements from the cache because they're no longer needed. Don't do this in the critical path. Just delay the garbage collection until a point where the user events have been treated, the page has been repainted, and so for that you can wait for like a set timeout of 0 or 15 milliseconds, or wait for an animation frame. Yeah. Another thing that can have low priority is if you need to do some sort of prefetching. You want to fetch some data and pre-process it so that when the user needs it, it's present immediately. Just also, again, don't do this while the user is actively interacting with the page and slow down the user experience. Some tools that you can use for both of these things would be, as I was saying, set timeout or equivalently request animation frame, although I don't recommend using request animation frame because at the animation frame, OWL is doing work, it's patching, and so set timeout is probably a better bet. And this one we don't really use inside of Odoo, but if you have pre-processing stuff that's low priority that you want to do when the user is not interacting with the page, there's this native API called request idle callback, and this asks the browser to schedule work at a point where the user is not actively interacting with the page. This function optionally takes a second argument, which is a timeout, and this means that it will, in the worst case, be equivalent to a set timeout with that amount of time. And so if you need something done before 500 milliseconds and you want it to be scheduled at the point where it has the lowest impact on user experience, you can use this. Okay, the next one is doing things concurrently. People like to say that JavaScript is a single-threaded language. For the most part, it's true, but it's also a very concurrent language. And if you look at the finer details, it's actually possible to spawn worker threads from JavaScript. So there are many things that should be done in parallel. Basically, anything that's possible to be done in parallel should be done in parallel. The most prominent example is network requests. So if you need to make multiple network requests, ask the server about multiple different things, and the second request doesn't depend on the result of the first, then you should do them in parallel. And as I was saying, anything that's asynchronous that you can do in parallel should be done in parallel. And there are also some things that you should do off-thread. That's spawn a worker. Don't hog the UI thread, the main thread, the one that if you have JavaScript spinning in a loop, the user can't interact with the page anymore. Don't do expensive work there. And that's mostly heavy data processing. So if you're doing like sound processing, data processing for analytics, whatever, well, first of all, do them on the server. But if you really need to offload some of this work to the client, then do it in a worker thread. So tools that you can use, the first one is promise.o. I hope that everyone that writes JavaScript regularly knows this one. This one lets you schedule multiple promises to be resolved in parallel instead of waiting for one before starting the next. And so at the top, we have the bad example. We wait for A to come back before we even start doing B. And just under that, we have the correct way to do things, which is spawn both requests simultaneously and wait for them in whatever order they come back. And the same thing can be said about doing async stuff in loops. Don't await in a loop. Use a map and promise.o on the result of this map operation. The callback for, the callback for map can be an async function. So if you need to do many operations in parallel, but even these ones have some sort of sequence inside of them, you can have the callback of map be an async function. And then, as I was saying, worker threads. If you need to do something really expensive, you can spawn workers. This is probably not very fully working code. Workers are well documented. Look them up if you need to do some sort of heavy data processing stuff. And now we get to the last one, do it cheaper. And this is the one that people are most used to start doing first. You start looking at improving your algorithms using better data structures. If you can do any of the 6 points that we've talked about previously, then maybe you don't need to do this one because this one is the hardest. The other ones are just, well, call a function, slap a cache on it, just don't do the work at all or do it in a different thread. It doesn't involve any rewriting of the existing code, mostly just shuffling things around. This one involves actual work, and so you should do this last if you can. Some things that make your code cheaper to run are better algorithms and better data structures. And I'm saying better data structures because in a lot of the code that you will see, people are using arrays for everything, and arrays are a really bad data structure when you need to check for whether an item is present or whether an item is present more than once, this sort of stuff. So stop using arrays for everything. That's my #1 tip. If your use case calls for a hash map, use an object, use a map, use a set, use something other than an array. Okay, so some tools that you can use is, as I said, hash tables. And in this case, that's objects. So in the first example, we're looping on items once, and then a second time, and then if some condition is met, we're going to do something. And the right way to do things is to first build a map of the field that we're trying to check and associate items with some key, and then in a single pass, we can find if they're, like, we're checking this condition implicitly by looking up the object in the acceleration data structure, which is another object. And then surprise, surprise, more hash tables. Hash tables are really fast, so use more of them. In this example, it looks very similar, but if you notice inside of this filter, the first one has includes, so that means that we're going to scan the updated record IDs every time. And so if there are thousands of updated record IDs, this is really slow, and we're doing this once for every record. So this is basically order of n squared, whereas if your updated record IDs is just a set, and there's no reason for it not to be a set, then it's O of 1, and you can do this much, much quicker. And then the last one would be custom data structures, custom algorithms. For the most part, if you're using the built-in data structures, you won't need these. I don't advise that you write custom data structures or algorithms on the regular. It's easy to get it wrong. It's easy to write buggy code. It's more stuff to maintain, so if you can avoid it, avoid it. Sometimes your use case really calls for a custom algorithm or a custom data structure. In that case, proceed with care, test your code, make sure that everything is working, and also benchmark it, because sometimes you think that, well, this cool data structure, it's going to accelerate my use case by a lot, and then you benchmark it, and it's actually slower. So benchmark. All right, so now we get to the tools section of this talk. And we're going to start with the easiest one, the one that hopefully most of everyone here already knows how to use, console statements. Console.log is the most basic one. It's easy to use, but it has a lack of traceability. So if you're trying to assess whether a function is running slowly and you add some console.logs inside of this function, you don't know where it's getting called from, and sometimes this matters. Like if a function is getting called thousands and thousands of times, you probably, like the function itself is probably not the problem. You should probably just call it less often, and console.log is not going to help you with that. But as I was saying, it can still help you distinguish whether, like if some function shows up in a profile as being taking up a lot of the time, and you add a log statement to it, you can assess, well, am I getting a lot of logs or a few logs? And if I'm getting a lot of logs, it probably means the problem is up higher, this function is getting called too much. But if it's only getting logged once or twice, probably means that a function itself is expensive. So it can still be useful, even though it's a very blunt tool. I use it all the time. The next console statement that can be really useful is console.trace. This one is very precise. It lets you distinguish where the call is coming from, and so that can help in the cases where console.log doesn't tell you where your function is getting called. Console.trace will give you a full stack trace of every call that ended up tracing something. It's also super useful when debugging, like with an actual debugger, is impossible. And this can be the case, for example, if you have some performance problem that only shows up in staging or in production or in your CI environment. I use it all the time when I need to debug problems on our CI/CD on the run bot. The big problem with console.trace is that it's really noisy. If you have a function that gets called a lot, you're going to completely flood your logs with stack traces, and so use with care. This one I don't see people use often. It's console.time and timeend. It's basically equivalent to just taking some sample of the current time using either date.now or performance.now, and then at some point later doing it again and logging the difference. It does it automatically. And it supports labels. So if you do console.time and you give it a label, and then at a later point you do console.timeend and you give it the same label, it will tell you how much time has elapsed between the previous call and this one. And it's also more granular than using a profiler. So when you use a profiler, typically it will tell you how much time is spent in a given function, but not in a single call, right? It will just tell you, well, at some point the stack trace said that we were in this function and we were in this function in total for that amount of time, but it doesn't really tell you, well, this function was called 250 times or just a single time. All right, so now we get to more advanced tools that are actual tools and not just the language itself. Lighthouse. Lighthouse is a tool that's built into the Chrome DevTools. It used to be called PageSpeed. PageSpeed actually is still available. It's a tool by Google that lets you gather a bunch of information about the performance of your page, mostly centered around page loads. And now it's built into the Chrome DevTools, which means that you can use it even on pages that are behind logins and stuff. It's just a tab next to the Elements Inspector and the Source tab in the Chrome DevTools. This one is Chrome only because it's built by Google. And what's really nice about Lighthouse and what makes it a good first tool to use when you have some page that seems to load slow is that even if you're not a performance expert, it's going to highlight optimization opportunities. It will tell you where you can start looking and working to get your page to load faster and perform better. And it also does other stuff like SEO, accessibility. It gives you scores and actionable items to make your page more SEO friendly and more accessible. So maybe I can give a quick demo of the tool. Let me switch to mirror mode. Is this going to work? Seems to work. OK. So if I go on a 17 run bot, let's take a look at the e-commerce, because this is one thing that's very important to be performant even on mobile. And you can see that here I have this Lighthouse tab. If it doesn't show up in your DevTools, it's probably hidden somewhere here under More Tools. So look for it there. Once you've shown it once, it should start appearing next to your other tabs. And so you can choose whether you want to benchmark mobile or desktop. There's a bunch of things that you can choose to analyze or not. Let me close this so that we don't have this annoying badge. And so let's do a quick run. Hopefully the Wi-Fi doesn't crap out on us. All right, and so as you can see, it gives you a bunch of composite scores. And since the e-commerce is something that's really important for customer acquisition, we've made many efforts to make it performant. And as you can see, it loads in 0.5 seconds. The largest contentful paint is, so that's the actual content that the user cares about. It's what takes the most of the page. It was shown in less than a second, which is great. Cumulative layout shift would be things moving around after the page has started loading, and you don't want that. It can make your users try to click on something and end up clicking on something else. So that's good. It tells you stuff about the total blocking time. Maybe I should use a worse example, because now I can't really show you all of the optimization opportunities. But you can see some opportunities here that it's giving me for accessibility and also for page speed. So these are for page speed, and for each suggestion, it also gives you estimated savings, which is great. So if you can reduce some unused JavaScript, it means your page can load faster, and it tells you, well, if you remove all of your unused JavaScript, like you can remove 500 of these kilobytes, then your page is going to load 0.4 seconds faster. And so that's really nice. But it's still a really blunt tool. It's mostly an exploratory tool. So if you have something that you already know is slow, probably not your best bet. But if you're looking for ways that you can improve the user experience, this is a good starting point. So the next tool would be the memory profiler. This one is also built into most DevTools. It's not Chrome specific. I'm going to probably make a quick demo of the ones in the Chrome DevTools. These ones are useful for diagnosing memory-related problems, obviously. And although earlier I was saying that since the session length in browser clients is generally hard capped because at some point the user has to refresh the page and the memory is going to be freed, sometimes you can still end up with memory leaks, like actual memory leaks, not just unbounded caches, and you can use this to solve these problems. But memory can also have unexpected impacts on actual page performance, and this is what's typically called garbage collector thrashing. And this happens when you're allocating lots and lots of small objects or big objects, and you don't need them for very long. The browser still has to garbage collect them, and the more objects you're allocating, the closer you get to whatever memory the browser is willing to give your program, and you're forcing the browser to collect garbage very regularly, and by doing that, you're making the page less interactive. So maybe a quick tour of the memory profiler. Again, you can find it here. It has a bunch of modes. Heap snapshots is quite useful to debug actual memory leaks because you can see on the static snapshot whatever is going to take the most memory. Maybe let's take a quick snapshot. Should be quick on this page. And so you have a bunch of objects. We can see that here what's taking a lot of memory is compiled code. This is probably because OWL compiles templates into functions, and these functions then get compiled by the browser into like actual bytecode that it can run inside of its VM. So this doesn't seem like anything to worry about, but I'm going to say it right now, there's probably not a memory leak on this specific page. And then if you click on any specific object from a specific category, you can see here the retainers. Retainers are ways in which the browser thinks that this object is still needed. And so in this case, you can see that we have this internal node. Internal node typically refers to the internal representation of an HTML element, sometime of an object. And here we can see that it's retained by the inspector overlay host. So it's probably some object that at some point was logged to the console. And so to keep it available to the dev tools, it's retained by the dev tools. So this is also something that you should be wary about when you're debugging memory-related problems. If you're logging stuff to the console, you're leaking memory. And so just log either copies or log string representations, or simply don't log stuff, or only log stuff that you know is not the problem. So that's for the heap snapshots. And then there's the allocation instrumentation on timeline. This one, we're not going to see anything if I start it because this page doesn't really do anything. But this one is very useful for garbage collector thrashing, because typically what will happen, maybe I can see if I can show something happening. Yeah, so you can see here there are lines, and these lines represent the amount of memory that was allocated. Whatever is in gray has already been reclaimed, and whatever is in blue has not yet been reclaimed. And typically when you have garbage collector thrashing problems, what you're going to see is you're going to see a blue line show up, and then another blue line will show up, and the previous one will become gray because all of this memory has been freed. And you can see this pattern continue. And so at that point, what you do is you stop the profile, and you look at the last blue line, and these are the objects that are being allocated frequently and then reclaimed a few seconds later, and that are causing the garbage collector thrashing problem. All right, so that's it for the memory profiler. For the performance profiler, this one is hopefully the one that people know the most. It's built also into most dev tools, and it's not Chrome specific. And it's the best bang for your buck. What it does is it gives you a flame graph that's in time order of all of, it takes basically samples of the JavaScript stack trace, and it tells you, well, we are spending most of our time in this piece of code or this piece of code, and it has some useful way to organize the data to pinpoint where the problem is. Yeah, and what's also nice is it lets you import and export profiles. The default view of the performance profiler, let's make a performance profile. So if you click on the button that you see here, it's going to reload the page, start a profile, and stop automatically once things have stopped happening. It also has some useful timings here that were given previously by Lighthouse. The DOM content loaded event is the point where the page is actually loaded. The first paint is when the browser has shown something to the user. the first contentful paint is the first paint that contains something. So sometimes the browser will paint a white screen. This means that the page is loaded, but there's nothing to show to the user. And then there's the load event, which is when most JavaScript will start running. And so if we zoom in this, you can see, so this is what's typically called a flame chart. In this case, it's in the other direction, so it's sometimes also called an icicle chart. And so if you click on one of these slices, you get a summary. And so let's say I click on here, this define. It also gives you a link to the place in the code where this is. And so if you find something that's expensive, you can just easily find it directly in the source code. If you go in bottom up, you have probably the thing that's most interesting to everyone. On the left, you have self time. So this is time that's spent in a function and not one of the other function that it's going to call at some point. And if you look at total time, that's the time that's spent in the function in total, including calls to other functions. So the best opportunities for optimizations are typically in self-time. If you see something is taking a lot of self-time, this is where you should look. And in this case, you can see that we're spending a lot of time in system locale. This is expected, like computing how to format times and dates and numbers. It requires the browser to communicate with the operating system, make sure that it also has all of the format strings and stuff available. So nothing unexpected here. And so as I was saying, you can export these. So this is a time order flame graph, but sometimes what you want is, what's it called? You want to have the heaviest things show up on the graph instead of having to dig through bottom up, especially since bottom up sometimes elides some of the stack frames. So let's save this trace. And then you can use a tool like speedscope.app to load this profile. And so this one in the default view gives you also the flame graph in time order, but you can put it in left heavy. And this one, it gives you a much better view of what's costing you a lot of time. And so the most expensive things are on the left. And then it also gives you a sandwich view. And this one is basically the same as the bottom up that you see in Chrome, except this one doesn't elide stack frame. So if sometimes you feel like you know a function is taking time and for some reason it doesn't show up in Chrome, you can export the profile and look at it in Speedscope instead. Okay, so that's mostly it for the performance profiler. And then the last one is, as a bonus, the Owl DevTools. The Owl DevTools are available right now in the Chrome extension store. You can download it. It has a rudimentary profiler, which might become more advanced in the future. It would be nice if we could export also flame charts of component rendering times. At the moment, we haven't really had the need to, so we haven't invested the time. But if it's something that you would like to see, please let us know, and maybe we'll bump this up in priority. What's really great about the Owl DevTools, which is something that's typically difficult to do but becomes trivial with them, is it lets you jump to the compiled code of a component's template. And also to like the code of the class itself. So if you've been here for the demo of the Owl DevTools, you've probably already seen this. Let's log into the runbot. And so the Owl DevTools also show up as a tab in your DevTools. And they give you a tree of components, and then you can also pick components. It shows you for components if they observe state. So for example, here we have the switch company menu, doesn't care about anything, but the expiration panel, it cares about some stuff. Like it cares about the state of your subscription to know whether it should render at all, that sort of stuff. And so as I was saying, if you right click on any component, you can jump to the code, inspect source code. Takes a while to load. And then we have the actual JavaScript code that was written for the component. This is the class of the component. If you are in debug assets and you have source maps, it will look exactly like the code you actually wrote. And because our tooling does some transformations on your code, it doesn't look exactly like this, but in most cases, this is close enough. And the one thing that's actually really hard to do without the Owl DevTools, it lets you inspect the compiled template. And so this is the JavaScript code that's emitted by OWL as the equivalent of the XML code that you wrote for the template of this component. And this is not that easy to read, but what's really nice about this is in the OWL DevTools, when components render, you can see that they flash in yellow. And so sometimes you have components that flash in yellow and you have no idea why. Well, what you can do is jump to the compiled template and then set a breakpoint on the first line of the function. And when this component re-renders, maybe I can do this with a component that I actually know how to render. Let's do this one. So now, maybe not this one, actually. So let's do this one because I know that this one, I can just toggle the number of notifications and it should be fine. So I set a breakpoint, and then when I open it, you can see that the breakpoint has activated, and you can scroll down and go to the first stack frame, and it tells you where this render was triggered. And in this case, it's some event listener. Main event handler is some code internal to OWL, and then we get the actual user code that triggered this render. And so for parasitic renders, it lets you find precisely what's causing them, and this will let you know how you can resolve them and avoid rendering stuff when they don't need to render. And I think that's it. So if you have any more questions, please feel free to scan the QR code and add them on the pad. I'm gonna toggle my display to be able to read them and keep the QR code on screen. Okay. So first question is, how can we do off-thread work inside of Odoo? And the answer to that is the exact same way that you can do off-thread work outside of Odoo. There is nothing specific about Odoo. Just spawn a worker thread, make sure that the JavaScript file is hosted somewhere that it's accessible to the worker, so in a static folder, and then just run your code and communicate with it. At the moment, we don't have any Odoo-specific tooling, but I don't think we need any. The native API is really nice to work with in the first place. Do you have any example of bounded, unbounded cache in Odoo? I don't have an explicit example in mind. So a very common example that you will find inside of Odoo is in Python code. We have a bounded cache. This one is called, if you see the annotation at LRU, this means at least recently used, and this is a cache that's bounded. You can configure it. I think the defaults are generally fine, and it will evict items from cache as they get used less and less, and it has some cap on the size. This is to avoid memory leaks on the server. As far as unbounded cache, as I was saying earlier, we have one that's set up for you automatically when you call memoize. And also for things like views, we compile view architectures into OWL components, and this one is also an unbounded cache because we assume that if view architectures changed, the user should refresh the page. Will the DevTools be available in the Firefox extension store? Funny you should ask, it has been available on the Firefox extension store since, I think, 2 weeks now. So, yeah, it's available. You should use it because we don't really use it a ton internally. So if there's anything that's broken, please submit a bug report, and I will forward them to our DevTools expert. Any advices for WebSocket connection optimizations? I'm not exactly sure what kind of advice you would like. Typically, this is not really a performance bottleneck. The way that we use WebSockets is for lightweight message passing. The WebSocket itself is typically not really a problem. So if you would like more specific advice, feel free to rephrase your question and add it back on the pad. Any advice on using long polling? We just talked about WebSocket. We don't really use long polling anymore. This was the way that we used. Did real-time message passing between the server and the client previously. Long polling is you just keep an HTTP connection open, and when the server needs to give data, it just sends it on the open connection. This has some problems. The first one being that for the longest time, browsers would only let you open 6 concurrent HTTP connection from a single web page. So by using long polling, you're using one of those. Recently, it's been bumped, and I think now in Chrome and Firefox, it's something like 25 or 35. So this is less of a problem. It's still annoying to have to restart a connection every time you want to be able to receive a message. So now we use WebSockets. I'm not sure there's anything specific to be said about the performance of either solution. This is just message passing again. So no specific advice really. Where could we have the slides used in this presentation? Let me. That's not it. Escape. I'm gonna just put them in the pad. Oops. I think I lost it. That's not great. Give me 1 second, and I'll add them to the pad. Well, I lost them, so I guess maybe later. Okay. Next question, if I can find it. Does all the legacy widget defined in Odoo define have been migrated on Odoo 17? I'm not sure what this has to do with JavaScript performance. The answer is most of them, yes. Is it possible to have, I'm going to guess this is SPA with OWL and use OWL as pure headless? I'm also not exactly sure what you mean by this question. You can have a single page application with OWL. You can do server-side rendering with OWL if you run OWL in a Node.js environment. OWL does not support hydration, so you can't render stuff on the server and then graft live components on top of them to start making it interactive. It's not something that we need, and so this is not something that we have allocated time to, but pull requests are welcome. I know it's not totally related. I want to know what's the right way to expose a web service, for example. JavaScript. Honestly, I don't know how to answer this question. How hard is it to migrate JavaScript from older Odoo versions to OWL? Do we have to rewrite all custom code? For the most part, yes. But hopefully, it's easy to write this code. The documentation for OWL is pretty solid. We also have tutorials in the Odoo documentation on how to use OWL specifically within Odoo. When we migrated all of our internal code, most teams had absolutely no issue getting started with OWL and rewriting their code with OWL, and they find it to be much more maintainable now. So the question about being headless has been completed to talk about Odoo headless. I mean, again, I'm not exactly sure what that means. Odoo is headless. Like, yeah, not sure what this means. All right, I don't think there are any more questions. If there are still questions in the audience, feel free to raise your hand. All right, I think that does it for this presentation. Thank you very much for your attention.